increasingly aware of its impact on the environment. We see renewable energy, more environmentally conscious production methods, as well as the use of sustainable materials that help propel the rise of green vehicles, green buildings, and other green products. Popular as they're becoming, not a lot of information is known of how these materials react to an explosion. Yet there is so much risk in what occurs in an explosive load that can have devastating consequences on the economy, the environment, as well as ourselves. Our research looks at the impact of explosions on these composites. So it's about understanding what effect blasts have on composites that contain sustainable materials. So a composite, if we are not sure what it is a combination of two or more materials. They are appealing and widely used because you can combine favorable properties of these materials and tailor them to different applications. So in this project, we looked at composites made out of two building blocks, so fiber and resin. A polymer resin was reinforced by the fibers, and there's just the fibers that gives it the strength of a composite. So at least one of those building blocks was made from a sustainable material. These composites were then tested under an explosive load. And to do this, we designed a simulation environment where 7 types of composites were tested under something called a uniform loading condition. So this is where we put the explosive from far away, so the exposed area of the composite would be impacted. So we also detonated different masses of explosives to get different force magnitudes onto the specimens. We felt that this was the way to do these tests because any close contact with the material might have disintegrated the composite, as well as it is a real-life world situation that can happen on structures. We found that composites that were reinforced with plant fibers, which is one of the sustainable materials, were quite weak. So this validated our hypothesis that they would have an inferior blast property when compared to synthetic composites that were made from glass. We also looked at changing the resin, yet keeping the same type of fibers, and found there was very little difference in the type of failure. So this project is really about quantifying what happens to a material to a blast load. It is not about finding the perfect sustainable material that's impervious to blast, but really to understand the material behavior and develop numerical models on them. We hope that by understanding more, we can mitigate some of the effects that blast loading can have on structures. Thank you.